All right, folks, one last quick hit from Module 2, and it's just that these two terms tend to trip students up semester in, semester out. So I want to try and make sure you're clear on which one is which, so that when I ask you for one, you give me what I'm looking for. Mass number, you might recall we talked about while we were discussing the atomic model. This is a count, okay? This is an integer no matter what. Just kind of take that to heart. If you see number, we're looking at an integer. Okay, so what I mean by that is this is your number of protons plus your number of neutrons. This is always going to be a whole number, and bear in mind, the same element can have a variety of different mass numbers because it usually has more than one isotope. By contrast, the average atomic mass is a measurement. It is something that is going to probably have decimal places in it. It's going to have this sort of look. And this is the one that appears in the periodic table. Whereas a given element can have several different mass numbers for each of its isotopes, it always has one average atomic mass. And I'm going to let you know right now, there is something I'm almost certainly going to slip and call this. Your book doesn't use this term, but I prefer it from the work that I've done in the past, and that is the atomic weight. The nice thing about this is if I call it the atomic weight, and we call this the mass number, notice how they no longer have any words in common. But the periodic table number, the atomic weight, is an average, it's a measurement, there's only one for every element. The mass number is an integer, it's a count of a number of particles. It's a property of a specific atom, and a given element can have more than one of them. I hope that clears things up. If it hasn't, I would recommend strongly that you come see me in student hours before we reach the point of having an exam on this, because it's something you're going to want to be sure you can keep straight. Talk to you soon. Bye.